Today, let's talk about pancreatic development. Of course, people nowadays enjoy sweets. Although they look appetizing, there's still a lot of sugar in those desserts. If those sugars start to accumulate without proper treatment, people will start to gain fat. However, the pancreas in the body regulates the sugar level to inhibit such accumulation.
That's damn good.
That's why the pancreas is so important. Now, the question comes to, how is the pancreas formed in the body embryonically? Well, that's what we're gonna learn today. Soon after the egg is fertilized, the blastula forms. The early gastrulation process forms into 3 distinctive layers, which are ectoderm, mesoderm, and endoderm. Which one do you think it's gonna be? Right, the pancreas is derived from the endoderm. So, after approximately 35 days since the egg was fertilized, there were 2 pancreatic buds formed. The smaller ventral pancreatic bud on the left side and the dorsal pancreatic bud on the right side. Soon after the buds are formed, rotation starts to occur. Unlike the cortical rotation, it is actually called the malrotation. Let's take a closer look from the top view. The rotation itself is actually unidirectional. Then, what's the next step? During the 6th week, when the ventral bud is fully rotated and under the dorsal bud, the ventral duct forms into the uncinate process, and the dorsal bud takes care of the rest. Still in week 6, what happens is that once ventral rotates and meets the dorsal, the duct fills into a main pancreatic duct. Interestingly, not everyone has the accessory pancreatic duct. After the process of fusion of pancreatic ducts, we will eventually have the initial pancreas formed. Of course, some people might be interested in what is causing all of those to happen. There are 4 important cell signals: sonic hedgehog, notch signaling, PDX1, and TGF-beta. The inhibition of sonic hedgehog leads to the budding of pancreatic development, and it is regulated by the TGF-beta. At the same time, the PDX1 marks the location of the budding. Lastly, the notch signaling promotes exocrine cell differentiation and progenitor cell proliferation. Now you have learned all the basics of it. You might be still confused about this process, but since the scientists know so little about it, they don't know either.